All right, question 10. We already have this in factored form, at least the denominator in factored form. Normally, like honestly, it wouldn't be a bad idea to see if this numerator factored, right? If it did and something canceled out, we would have made our lives a little bit easier, but x squared plus 12x minus 5 doesn't cancel out nicely over the row numbers. All right, so when we look at this, right, we have three different factors here, right? So I'm just going to focus on our fraction, and then I'm going to do the actual derivative, antiderivative in a bit. So we have three different terms, right? I have an x plus 1. I have another x plus 1 squared. That's why I have a repeated root, and then I have an x minus 7. All of those are linear terms, so we're just going to get an a, we're going to get a b, and we're going to get a c here. All right, so then same thing, we would multiply both sides by the least common denominator, and that's going to give us x squared plus 12x minus 5 equals a times, we're going to get an x minus 7 times an x plus 1, right? So one of these x plus 1 squares, right? One of them cancels out, so we're just left with 1x plus 1, just in case. We're going to get a b. Right, so the x plus 1 squared is going to cancel out. So just times an x minus 7 plus a c. The x minus 7 cancels out, so we're left with x plus 1 squared. All right, so then let's plug in some numbers. So kind of two nice choices, right? We can say, let's say x equal -1, but that's going to cancel out some stuff for us. So when x is equal to -1, this term goes away, this term goes away. So we're just left with -1 squared. So we get 1 minus 12 minus 5. There's such a chance that I mess up some arithmetic here. So this is going to be -16. B, -1 minus 7 is equal to -8. So B is equal to 2. If we let x equal 7 here, so let x equal 7, then this goes away, this goes away, right? And we're left with 7 squared. 49 minus 5 is 44. 12 times 7 is 84. 44 and 84 is 128. We're going to get 7 plus 1, so 8 squared, which is 64. 64c is equal to 128, so c is also equal to 2. Right, and then here, now is where we have to make a choice, right? Because we can't plug in anything. It's going to cancel anything out. So this is where we usually say something like, well, let's let x equal something nice, like say 0. All right, so this is going to be -5 over here. We're going to have a times 0 minus 7, 0 plus 1, so -7a. We already know that b is 2. It was 2, not -2. 2, so 0 minus 7, so -7. We already know that c is equal to 2, right? So that's going to be another 2. Right? 0 plus 1 squared is just 1. So we're going to get -5 is -7, my 7a, minus 14 plus 2. That's so -12. If I add the -12 to the other side, I get 7 is -7a. So a is equal to -1. All right, so we have our terms, -1, 2, and 2. So this antiderivative is going to be the antiderivative of -1 over x plus 1 plus 2, it was 2 over x plus 1 whole quantity squared, plus 2 over x minus 7 dx. All right, so some of these are going to be kind of nice. So if we look at -1 over x minus 1, that's going to be negative natural log x plus 1. I'm actually going to do the 2 and the x minus 7 one next, because that's also going to be easy. 2 absolute value of x minus 7. The 2 over x plus 1 squared, well, that's not going to be a natural log, right? If I have the antiderivative of 2 over x plus 1 squared, right? So we could do a u substitution here. If we have x plus 1, we're going to get a du of just dx, right? And this is going to turn into 2 over u squared du, aka 2 out front, 1 over u squared, right? So the antiderivative of u squared is going to be negative 1 over u, that thing times 2. So we're going to get negative 2 over x plus 1. So we're going to get minus 2x plus 1 plus the constant, and this is our antiderivative.